So, October 27th, T minus 4 days until Mr. Wolf's birthday. So, you can start planning ahead on Halloween. Yes, big party. Everybody dresses up and gives out candy for my birthday. True.
Your birthday's on Halloween?
It is.
Oh,
every year it falls on Halloween.
Just you wait for the announcement on Monday.
Oh gosh.
Yeah, you shouldn't have told Preston.
Preston, who willing to pay people to jump in rivers. Anyway, example number 2. Here's the velocity. Find the acceleration at time equals 2. So, like, conceptually, this isn't too bad of a problem, right? Because acceleration is derivative of velocity. Then we'll plug in 2. And the trouble is, the derivative of velocity is product rule, yeah, with natural log involved.
Yeah.
Okay, so an especially yucky product rule, which means, to me, it means I'm going to come off to the side, find f prime, write it down, find g prime, write it down, and then put it all together. On easier product problems, I might just kind of do it in place, derivative of one times the other, plus the other way around, but that's too much to keep up with for this problem. Okay, derivative of natural log is 1 over the argument times the derivative of the argument, which actually turns out to be not too bad for this problem, 2 over t. So as ugly as it looked, wasn't nearly as bad as we thought. So first one times the derivative of the second one plus the other way around, the second one times the derivative of the first one, which was just 1. All right, that's not wrong. Let's just clean that up a little bit. So the t's cancel.
2 plus ln t squared.
The 1 doesn't really matter. So 2 plus natural log of t squared. Is that the answer to the question?
No.
What do I need to do?
It.
Plug in 2. So a of 2 is 2 plus natural log of 2 squared. 2 plus natural log 4. And that's an exact answer, so we're good with that. All right, everybody grab a calculator. So mine are on the shelf back there if you need to borrow one. If you got your own, that's fine too.
Are you going to want us to make sure it's in radian mode, or are we not dealing with that today?
Radians matters when you're doing cosines and tangents, and there is a cosine coming up, so may as well make sure you're in radians. This one wasn't. So yes, make sure you're in radians. In calculus, you will always be in radians. You will not ever be in degrees. In physics, you're usually in degrees. So be careful when you use your own calculators and you're moving back and forth between physics and calculus. Be careful.
That's why I asked. I wanted to make sure.
Okay, 2 ways to do this problem in the calculator. I go back and forth on which way I like better, so I'm going to show you both, and you can kind of figure out from there. Let's go to y equals, and let's put that in. So y1 equals t times natural log of t squared. Let's just do x's then. You can just do x's. You can make a variable swap. Your calculator doesn't know that the original problem was written in t rather than x, so the calculator's fine.
Where's the natural log?
He doesn't know any better. Natural log's over on the left-hand side toward the bottom.
Alright.
X times natural log of x squared.
Ooh, that's a cute little graph. Is it dead?
No idea what that graph will look like.
Nick has a dead one. Do you want him to leave it somewhere special so it'll get...
Just don't, Nick, don't put it back in the case. Set it on the side somewhere.
Go set it on your desk.
Let's see. Okay, has everybody got that far? So I've graphed it.
I can't find LN.
Bottom left.
I know.
Not bottom left, but third from the bottom left.
Okay.
Okay. All right, is everybody here? Because we're about to hit a very particular set of buttons. So I want to make sure you're at this screen before we start down the path of buttons. Nick, you find one yet?
He has an app on his phone.
Here you go. Use this one.
I'm sorry.
Is it?
Maybe use this one. There we go.
Alright.
You just
Thank
got
you.
bad luck.
Use that one.
There, you can use my extra one.
Oh, nice. That's not bad.
All right, what I would like to do is some calculus. So, second calc. Second calc. And then I see some options. Some of those you've used before, some of them you haven't used before. If I would like to find the derivative of velocity,
You go to 6.
6 says dy dx, so let's go to 6 dy dx. Press enter. Second calc.
And then you press the 6 button.
And you can press the 6 button, or you can scroll down to dy dx. And then you have options. You can scroll, but scrolling
Is yuck.
you're probably not going to land exactly on. We're trying to land on 2. So rather than scrolling, just hit the button 2, and it says x equals 2.
What? That's been an option this entire time?
Yeah.
I know. That's been an option this entire time for you to use the calculator.
Miss Murray always made us scroll.
And dy dx equals 3.386.
Oh no, man, what just happened?
The calculator found a numerical derivative, found the slope at that point for us.
Do we have to go over the second way to do it?
Just to verify that we got that right. At this point, I don't know if I'm checking me or checking the calculator. But 2 plus natural log 4.
Wouldn't it be 2 times natural log of 4?
It's sure heck. It better be the same thing, and it is. Sigh of relief. Julia.
Wait, why is it that when you calculate in the calculator it's 2 times natural log, and then the other one is like
Okay, because I plugged in the calculator the original,
Yeah.
because I want the
Oh.
right. I don't want to have to take a derivative. That's the whole point of using the calculator. Is, you know what? The calculator can find a derivative. All I have to do is plug in the original. Yeah, it's cheating. Now let's see if I can remember the other way to do this.
Let's not read the C word.
Math. Yeah, there it is. So go to math. So exit out back to the main screen. Math. Scroll down. In derivative, meaning find a derivative. I don't usually do it this way, so I'm going to just see if the prompts will remind me what to do.
Mine doesn't do that.
If you have an older software, it may not do that. You'd have to know the. I would borrow one of mine because.
No, it works the other way.
Okay.
So-
Yeah, just do it the other way. It's fine.
Yeah.
You want to do it again?
If yours isn't showing that, can I borrow yours?
Yeah. I cleared it. It's the same buttons.
Math what?
Math, whatever in derivative is, 8.
That's
Oh,
FM.
yeah.
I feel like an old person trying
If
to
that
get
does that, don't.
Sounds like it.
So, if your calculator shows this, you can still do it. You just have to know the right order of things. I wouldn't do it.
Yeah.
I'd use a different calculator.
Or what about just the first?
How would you?
You could do the first method though.
How would you? I want to know how you.
Remember
would
the
do
two
it.
methods?
Function, comma, variable, comma, value.
So you would put like X or.
So we're taking the derivative with respect to x of x times natural log of x squared at x equals 2. d dx of x ln x squared. Evaluate that at x equals 2. Good. And then, so yes, all these times you've evaluated derivatives, the calculator can do that. You probably knew that, but now the cat's out of the bag.
Now I know. So we get a calculator on the rest of the sentence.
And then one more way, although you wouldn't do it the way I'm about to do it, because if you already typed in the variable, you wouldn't use this way, but if you've already got y1 typed in, then you can just tell the calculator, hey, take the derivative of y1 at x equals 2 and tell me what you get. Now that's a combination of the two methods, so why would you do that one? But the calculator can handle it. All right, example 3. Definitely with calculator, because you do not want to be taking a derivative by hand of that thing. Right? Because that would be product rule, chain rule with a quotient rule, and then double chain. You'd be a mess. Yeah, in theory you could find that derivative by hand, but we're not going to ask you to do that. Find the acceleration of the particle at t equals 2. You know what? I'm going to press pause. You see if you can get your calculator to give you that derivative. So sine of x cubed over 1 minus x, close parentheses, cosine of natural log of x squared, closed, graph, who knows what that looks like.
Oh yeah, mine doesn't look like that.
Mine does look like that. And it's
So that is, who knows what that is. The cosine and the sines are what makes it periodic, but other than that, second calc, dy dx at t equals 2, 1.079.
Now mine looks like that. I forgot parentheses. Freaking parentheses, man.
What do you think I did wrong?
Check your parentheses.
Put as many parentheses as possible.
All right. Spam parentheses. But they got to match, though, is
But
the
it's
problem.
feet per minute, right?
Oh, yes.
Units of measure?
Units of measure for acceleration
Feet per minute.
is not going to be feet per minute,
Squared.
because velocity is feet per minute, so this will be feet per minute,
Or feet per minute.
or feet per minute squared. Because change in velocity is feet per minute, and then time is minutes, so feet per minute per minute.
This scares me. I don't like it.
Okay, number 4. Did everybody get to 1.079 eventually?
Yes.
Check with a neighbor and get the parentheses all spammed out, right? Number 4. Find the acceleration of the particle at time 2. Okay, so you can do that. You can find the acceleration at time 2. So try that. I'm going to press pause. Part C. Find the time at which the particle is farthest to the left.
But time has to be negative.
Time has to be positive. T greater than 0.
Oh.
So farthest to the left. So that would mean it's moving left, and then it changes and starts moving right. So what's happening at this spot over here? Like V is 0 because it changes direction.
Mm-hmm.
But can you be more specific?
Acceleration changes. Now we get acceleration.
V changes. How does V change?
Negative to positive?
Yeah. V changes negative to positive. So that tells me I can now look at my graph and figure out where does V, because that's the graph of V, it changes negative to positive right in there somewhere. Maybe a better window would help. So now I'm really zoomed in. So I want that 0. Do you know how to get your calculator to find a 0?
Yeah, second calc.
Second calc 0. And then it walks you through left bound, right bound, guess. T equals 0.443. And again, you don't have to say what you typed in your calculator, because if they give you a calculator, they know you're going to use. Yeah. Okay, today's assignment, 0.443, is only 1 through 4. And don't get too giddy, because we're going to do number 1 together. So grab the worksheet packet. Worksheet 3. Friday will be 5 through whatever's left. 5 to infinity. So let's try number 1 on worksheet 3. We got 10 minutes left.
1 to 4, you said?
Your final answers must be correct to at least 3 decimal places. So again, don't do more than 3, because then you might mess something up. Go to 3 decimal places. A particle moves along a horizontal line so that its position is given by. Find the instantaneous velocity at time 2.
Okay.
Okay, this is with calculator, so you don't have to show all the work, but you do have to tell me how you're going to find velocity at 2. So, how are you going to find velocity at 2?
Plug it in.
What is the velocity? How do you find the velocity? So, I'm going to say ds dt at t equals 2. Then I can go to the calculator and go from there. In fact, since there's like 6 parts to this, I'm going to y equals on this one. That way I can use y1 a bunch of times. Negative x cubed. So again, on the longer problems like this, strongly recommend you put that in for y1. That way, anytime you need it, you can just call it y1 and not have to type in the whole thing again. Make sure you type it in correctly, since you're going to be using it a bunch. Okay. I'm going to go back to Zoom Standard, because I don't know what I had been doing, zooming in and out.
How do you reset it to Zoom Standard?
Press Zoom,
Yeah.
and then one of the options is Standard.
Does that reset your window?
Zoom Standard goes -10 to 10, left and right. And then you can, change it, because it does say t is greater than 0, but, okay, so I want the derivative of that at 2, so second calc, dy dx at 2. This is a good one to do. That's what mine says. Does anybody have a different answer there? Did anybody give them to exactly 2?
No, that's the case where you just truncate.
So you can truncate or round. My guess is it's exactly 2. And rounding it gets you to 2.
Well, yeah, but it's just because that's the calculators.
Okay, find the acceleration of the particle. Well, that's a second derivative. And there's not a second derivative button in the calculator.
So you have to.
So watch this trick we're going to do. I'd like to graph the velocity. So on the graphing screen, on the y equals screen, go get that dy dx thing, math 8. And you can say, I want the derivative of y1.
How do you get y1 in there though?
y1 is a variable, so you go to vars, yvars, function, at x equals x. This is crazy, but this is you trying to tell your calculator, hey, graph the derivative of y1. Not just at one spot, but at all the spots. It usually takes a while to do this because it has to calculate all those derivatives.
Help. Because mine is the older model, remember? Oh.
So vars to get to y1.
Yeah.
I'll just start all over. So math 8 gets me the derivative
Yes.
with respect to x. And then I want a variable. I want to use one of my variables. So vars, it's a yvar and it's a function. y1. And then be careful, if you just put in x equals 2, it'll find the value at x equals 2 and just graph that the whole way across. But you want all the different x's.
Mine's giving me a syntax error.
And it takes a while because it has to go at each spot, calculated derivative here, calculated derivative here, calculated derivative here, and on and on and on and on.
Mine's the end derivative, remember? So how do I plug it in again?
And then second calc.
Yeah.
Now I want the derivative of that at 2 is 2. Now, since this one was a polynomial, it might have been easier just to do it by hand, but I'll help you in a minute. Or grab a calculator that you don't have to do that on. When is the particle at rest? That would be when velocity is 0. So I think I'm looking at the graph of velocity right now. So second calc 0. Let the calculator do all the work. T equals 1.451. And do that again. Second calc 0 at the other one. .215. It's moving to the right when v is positive. Well, I'm staring at a picture of velocity. So that would be from the first 0 to the second 0. 1.451 to 3.215. Moving to the left when v is negative, so that'd be, well, but we start at 0, so 0 to 1.451 and 3.215 out to infinity. Alright, the trick will be when you get to total distance. But try 1 through 4. All we're going to do tomorrow is work a bunch of these together. So nothing new tomorrow. We'll just work some together.
Do you like the chocolate, Mr. Wolf?
I'm good, thank you. You're just throwing them out, huh?
I mean, I don't like dark chocolate.
Very unfortunately.
Chocolate bar?
But there's a couple over there.
You can split it between you two.
What is truncate?
Truncate means don't round, just drop the rest of them.
Just drop the decimal.
So drop the decimal. That's legal.
Because we're doing that in computer science right now.
Yeah. TRUNC or something, yeah. Yep. Trunk.
Still, that's energy.